Good. Fine. So, fine. Right. So before discussing about this Ab Initio, so we have to see some things about warehousing because first we have to know what is the need of this Ab Initio tool, right? So we have databases. So our databases can handle any huge number of transactions of the client. I mean transactions of the customers for the client. So if you have any bank or insurance organization, so every organization is going to database nowadays to handle all the transactions of the customers. See, after storing million number of transactions in the database, if the client wants to do some kind of analysis on the data, like how many number of customers I have in this year and how many number of customers I have in previous year. Similarly, how much deposit made by the customer in this year and how much deposit made by the customer in last year. So those kind of analysis the client may want to do to know the customer, to know the customers and to improve their business, okay, to take some decisions and all, right? So then he has to strongly consider the data warehouse because if even though he has a database, so he is not supposed to store entire transactions in only one database. He has to separate the history into another database, right? So to maintain the history of all the customers, we need a separate database. We will call the database as a warehouse because with the help of this warehouse, my client has to do some kind of analysis by tracking entire history of the transaction, right? So now, so we have a basic idea why we have to go for data warehouses. So now my job is I have to move the historical transactions from databases to data warehouses. Okay, so this database I will call as OLTP. Right, so OLTP stands for online transaction processing. So all the transactional data will be stored in the databases. So this transactional data I have to move periodically to the data warehouses. These data warehouses are analysis systems. So that's why I will call the data warehouses as the online analytical processing systems. This is high level overview about data warehouses. We will discuss more in our regular sessions if you need. Okay, so now to move the data from databases to data warehouses, we need the ETL tools because I have to perform the extraction operation from multiple databases, okay, and I have to apply some kind of business rules on the extracted data, right? So these business rules may include finding out the number of transactions or finding out the sum of transactions of the customer, sum of deposit of the customer. It can be any kind of aggregation. So I will call all these things as the transformations. So once the transformations are done on the extracted data, I have to load the transformed data into the data warehouse, right? So entire this process we will call as ETL, extraction, transformation, loading. To apply this kind of ETL operations, we need ETL tools, right? In the market, we have Informatica, DataStage, Ab Initio, and other tools to perform this kind of ETL operations. So among all these tools, Ab Initio is the most famous tool and most powerful tool because it has some parallelism kind of techniques. Okay, so this with the help of this parallelism techniques, you can apply the transformation on the huge number of records in seconds of time. It gives better performance. It gives tremendous speed to apply the ETL operations. Right. So this is about ETL tools overview. So now coming to this Ab Initio. Okay. So Ab Initio is a Latin word which is derived from the Latin. It is not an English word. So which is derived from the Latin word. So the meaning of this Ab Initio is from the beginning. Okay. So why they named as from the beginning here is, so from the very beginning, my tool can do all the operation without taking help of any third-party software. Like extraction, it has some utilities, and transformation also it can do without using any third-party utilities, and loading also can be done by Ab Initio itself. So for all these kind of operations, you need not do anything here. So we have the built-in library, rich library in this Ab Initio tool. With the help of this existing library, you can easily perform all the operations. That's why they named as from the very beginning, right? So now, before this Ab Initio Corporation, there was a company called Thinking Mission. They planned to implement a tool. The tool should be capable of scalable computing, The tool should support parallel systems, and so the tool is supposed to be running on the parallel machine. So by thinking in this way, they introduce a tool. The tool name is called Ab Initio, and the primary focus of this tool is so this tool can be used for data migration, and it can give high performance and better productivity. So these are the primary focus um, behind the tool introduced by them. Okay, so earlier days, the tool was capable of handling GBs of data. So nowadays, every client has TBs of data. So my tool can handle TBs of data as well as it has a big data capabilities as well. Okay, so next thing is, so this is the URL of the Ab Initio Corporation. They introduced the Ab Initio tool. Okay, so this tool can handle the application from simple to most complex. Okay, so now before see how to develop the code in my Ab Initio tool. Before discussing this topic, we will see the architecture of Ab Initio, how the Ab Initio will be installed, and what are the components we have in Ab Initio. Okay, we will see now. So this is the architecture of Ab Initio. Okay, this is the basic architecture of Ab Initio. So when you buy a product from Ab Initio Corporation, you will get basic three things. Three things you have to buy. The first one is Ab Initio graphical tool that we will call as GDE, so which can be used to develop the application. Second one is Ab Initio co-operating system. Third one is EMA, which we call as repository. So before talking about these three products, we will see about native operating system first. See, if you want to install any other third-party software, first you should have the native operating system in your machine. Okay, your native OS can be Unix or Linux or Windows or Sun Solaris, any kind of flavor, right? So you should have the native operating system on your machine first. So if you have the native operating system, so and when you buy the product from the Ab Initio, so you will get the graphical tool. Okay, so the graphical tool we will call as graphical development environment. Okay, so this graphical development environment I will install on my Windows operating system. So why they named as this tool as graphical development environment here is this graphical development environment contains the built-in components in terms of graphical symbols, like how we have the MS Paint icon. Similarly, in this graphical tool also we have the existing components in graphical format. We will just drag and drop all the components to develop the application. Okay, I will show you that now, right?
Suspicious items have
A
been
minute.
detected.
Since it got disconnected. Okay, fine. I'll show you that. Yeah. So with the help of these graphical symbols, you can just drag and drop the components onto your canvas. Okay. So that you can just connect the components. So for an instance, if you want to read any input file from the external source, you can just drag and drop the input file component as icon. You will just pass the URL of the input file. Okay, and it will read by the component. So similarly, if you want to perform any kind of sort operation, so like Unix or any operating system, here you need not write any code here for sorting operation. You will just use the sort component here. You will just pass the key for the component icon. It will take care of the sorting operation. So like that, for each and every operation we have existing components, you will just pass the parameter values for the components. It will take care of the rest, right? So like that, you have the components for each and every business rule. Right, so now with the help of this graphical tool I can develop the application. Okay, so in the application I may have the component suite. This component suite contains existing components. You can just drag and drop the components for this component library to your GDE. Similarly, if you want to create any user defined components, you can create with the help of the user defined components library, right? Similarly, if you want to use any kind of shell programming or C++ programming, that is optional actually, but if you want, you can use the shell kind of programming also in our GDE, right? So with the help of this existing components or user defined components, you can develop the application in my GDE graphical tool. Let me show you the GDE now. So let me start my virtual machine. So meanwhile, if you have any questions, you can ask.
Sure.
Yeah, it's let it open. So I will come back to this slide here. Yeah, so with the help of this graphical tool, I told we can develop the applications, right? So now I have an application in my Windows operating system. I want to run this application to produce some output or to load into database from database to data warehouse. Okay, so now to run this application, if you click on the run button, okay, so this graphical format cannot be understood by your operating system to load the transform data into warehouses, right? So because in case if you want to run the application on a Unix operating system, my Unix can understand the shell kind of syntax. Either you have to pass C shell or B shell, or you have to pass corn shell, right? So any kind of shell programming you have to do on Unix operating system. But you are doing graphical format here in your Windows operating system. Now you have to configure your graphical tool in such a way to connect with the Unix operating system, right? So when you click on run button, there is an interface between your graphical tool and your native operating system. I will call the interface as the Ab Initio cooperating system. So this Ab Initio cooperating system we will call as scope. Okay, this scope is the interface between the graphical tool and the native operating system, right? So this interface is supposed to convert the graphical code into the Unix understandable format, because my Unix cannot understand this graphical format. That's why if you install the cooperating system on Unix operating system, the job of this cooperating system is to convert the graphical symbols into the Unix understandable format. So this can be taken care by cooperating system automatically. You need not do anything. Okay, so let me come back to this one. I will show you the GDE product. Yeah, this is called graphical development environment tool.
Mm.
Okay,
Can I
so
ask,
this is a tool. Yeah,
ask a question? Um,
please go ahead.
can you go to your slide?
Yeah. Yes.
Okay, I just got confused about the GD, right?
Yeah.
Uh, there is the Cell and C++. Those are the programming language, right?
Yeah.
So, does that mean we can use those programming language in GD? Do you mean
Yeah,
that,
if you
or
want, you can use. Earlier days, before these tools were introduced by corporation, earlier days the backend tool for my graphical tool is the C++ programming. This is the backend tool actually. So with the help of this C++ tool, they might have introduced the GD graphical symbols. Like how we have some MS Word, MS Excel, MS Excel tools in our Windows. So the backend for this MS Word and MS Excel tools is Visual C++, right? So with the help of this VC++ programming, they introduced the MS Excel and MS Word tools. Similarly, for the GDE also, they might have used the C++ programming as a backend. That's why they have given the feature of the C++ also in GDE. If you want, you can write any C++ programming also. But nowadays, we have wide library in our GDE. That's why you need not work on C++ here. You need not learn C++ also. But if you want to use any kind of CPP kind of coding, you can use. That is optional actually, but that is not required here, because developers are not comfortable with the programming. This is not recommended to write any kind of complex coding in GDE, because to simplify the coding concepts, we have introduced this concept, right? That's why this is not recommended to use C++ coding. But coming to shell here, shell is recommended, because the thing is, so if you see this GDE here, so let me show you one thing, simple example. Okay, so this is my graphical tool, right? If I want to read the data from my operating system, I mean from my landing server, I had to use the input file component here from my dataset folder. So this is the component I have here. I will pass the path of my Windows or Unix operating system. If you take any Unix operating system, I will give the path like /var/bin some sample file /var/bin sample.data I am giving. So now the job of my input file component is it has to read the data from this URL, right? So what I want to do here is sometimes I may not see the file. I mean my file may not be arrived in my landing server, right? So my file may not be arrived at in my landing server. So before running the process here, I have to check the existence of the file in my operating system, right? I have to check the existence of the file in my operating system. If the file is arrived, then only I want to trigger this process, right? So to check the existence of the operating system, I mean to check the existence of the file in the operating system, you have to 1 minute. Mamata, just 1 second. Let me open the door. Yeah, sorry, Mamata. Yeah, see, what I am discussing here is yes. So I am reading an input file from my operating system, right? So before reading the file from my operating system, I have to check the existence of the URL. So without the existence of the URL, if I start the process here, my process will fail saying that no such file or directory, right? So to check the existence of the file, you have to write the syntax, right? I mean, you have to write a code here. So the code is, let me show you in Notepad, okay? So the code can be like, you have to use some kind of if condition here. Let me increase the font size. If condition you have to use, the code is if -f, okay. The file name is /var/bin sample.dat. So you have to check the existence of this file, right? If the file is existed, then only you want to start the process. Otherwise, you want to exit with some statement. You will write a statement here saying that echo file is not existed or not yet arrived, okay. So for these kind of things, you have to write the code in GDE. This kind of simple if statements you have to write in GDE, right? So this is the syntax which can be executed by my Unix operating system. So now I have to write this kind of shell programming in my GDE. That is why I included shell here. Got it, right? That's why we have shell here. So C++ is not required for you, but if you want to work on the graphical tool, some kind of basic commands are required to work on the GDE, because you may have to find out the number of records in the file with the help of some WC command, right? If you want to find out number of records in the file, you may have to use the WC command. WC-l file name you have to use. So this command gives the number of records in the file, word count. Okay. Similarly, if you want to create a file, you have to use some cat command. If you want to remove the file, you have to use some rm command. So some kind of simple file management task you have to do in Unix operating system if your client is going with the Unix operating system. In case if your client is going with the Windows operating system, okay, to install the Ab Initio co-operating system, you have to go for the batch commands. Like dir is the command in MS-DOS to list all the files, right? So copycon is the command in MS-DOS to copy all the files, right? This kind of simple batch commands you have to use in GDE for some kind of file management utilities, right? So that depends on the operating system, but 99% of the cases you can see only Unix operating system in your machine, because Unix is the most trustable operating system for the clients, right? So now what I am trying to say here is, this is called a graphical tool. This I will call as a canvas. If you want to do any kind of operation, you can use the existing components library here. So this is what I mentioned here, component suite. Okay, so this component suite you can see here, right? You have the built-in rich library here. If you want to read any data, you can use the input file component. Similarly, if you want to sort the data, right, you can use the sort component here. So you need not use any programming here. Drag and drop onto the canvas, connect the input data to the sort component here. You will just connect this one to my sort component here. Okay, your sort will do the sorting operation, right? So similarly, so if you want to do any kind of reformat operation, or if you want to find out any kind of aggregations, you can use the any aggregate component. Like we have some roll-up component here. This will take care of aggregation operation. Similarly, if you want to do any kind of join operation, you can use join component here. So this will do join operation, right? So for each and everything, we have the built-in library here. You will just connect all the components one by one. You will run the process. So when you click on run button here, so these graphical symbols cannot be understood by my Unix operating system, because my Unix can understand only shell environment. It cannot understand this graphical format. So your code should be converted into the shell format, right? So this job can be taken care by the Ab Initio co-operating system, which I install on top of the native operating system, right? So this co-op is the interface between the graphical tool and the native operating system, so which can be installed on top of the native operating system, which can be Unix or Windows. So I will install GDE on my local machine, which is Windows operating system. I will configure my GDE to connect with the co-op, which is installed on the native operating system, which can be Unix, right? When you click on run button here, your job will be converted into the Unix understandable format with the help of the Ab Initio co-operating system. This is automated process. You need not do anything with this co-operating system. You will work on GDE only. You won't work on the co-operating system. Okay. So this GDE internally internally will be executed by the Ab Initio co-operating system. Okay, so to understand simply, I am just simplifying the words here, but we have so many features for the cooperating system. Okay, we will discuss about all the features in our regular sessions. Okay, so now I will repeat again. I have the GDE. GDE stands for graphical development environment. Okay, so this GDE I will install on my local machine. So where I have the existing components suite and partition components, transform components, sort components, database components. I have many components in this component suite. Okay, so if you want to create any user-defined components, you can create user-defined components with the help of this component suite also. Okay, so now with the help of this component suite and user-defined components, and by using some kind of shell commands in GDE, you can develop the application. I will call the application as the user applications. Okay, so these user applications will be run on the native operating system with the help of the Ab Initio operating system. So the job of this operating system is, the primary job of this operating system is, which will convert the graphical symbols into the Unix understandable format. Okay, this is automated process. You need not do anything for this operating system. So the process of converting this GDE code into the native operating system format is called deployment process. Okay, so deployment is a process by which your graphical code will be converted and deployed into the native operating system, which can be run by the co-operating system, right? So now coming to the CME. So before discussing about the CME, so let us suppose I have done an application. I have created one application, right? So the job of this application is I am reading one branch of my bank data. Okay, I am sorting the data. I am doing some kind of modifications on the source data, and I am doing some kind of join operation, and I am doing some aggregation also, and I am loading into the some database or some data mart. Okay, so now the application is running for days and days in my production environment. So after a few days, I got a new requirement from the client saying that, so my client established a new branch. Okay, so he has given some rules to apply the same logic what I am doing for the current branch for the new branch, right? So now I have to modify the code which is running in live. I have to modify the code, right? So to modify the code, you are not supposed to override the existing code which is already running in the production. You have to enhance the existing code, right? To enhance the existing code, you have to save the existing code in a version, and you have to update the new code to the new version. right? So like if you have any MS Word document in your project, okay, so if you do any kind of modifications for the MS Word document or your project documentation, you will write a comment in the document saying that this is the version number, and you will save the new document with the new version number. Like that, for each change you will create a new version in the MS Word. Similarly, in this Ab Initio also, for any new change for the existing components, you have to create the new version, right? Because so you are not supposed to override the existing version, because the existing version may be used for one business requirement, the new version may be used for another business requirement. Like for each requirement you may want to use one more version. Like if you keep on increasing the existing code by with new versions on daily basis, you may get n number of versions in your project, right? So now you have to keep track of all the versions in the server, right? If you have some 100 versions for an application, you have to keep track of all the 100 versions in a server. So now for an instance, whenever a developer requests the code from my server has to provide the latest version. You should not provide the old version, because on top of the latest version only my developers will modify the code. Alright, so this is called version controlling. So now my job is I have to keep track of all the versions in my server, and I have to provide the latest version for the developer whenever he wants to modify the code, right? So this job can be taken care by one server. I will call this server as a repository. In Ab Initio, this repository is called as EME. EME stands for Enterprise Metadata Environment. Okay, so this enterprise metadata environment is the repository which keeps track of all the versions of my code. Okay, so whenever you develop a code, you are supposed to store the code in EMA. Similarly, whenever you want to modify the existing code, you have to get the existing code from EMA to your local machine, then only you can develop the code, right? So this EMA is a repository, or which is a server, so where I will store all the versions of my application. Okay, so where the version controlling can be done by this EMA. This is the primary job of my EMA. Version controlling is the primary job of my EMA. So for this EMA, we have many features. Okay, we will discuss all the features one by one in our regular sessions, right? So the basic thing you have to understand in our demo session is we have three products. The first one is the GDE. So I will install this GDE in my local machine. So GDE stands for Graphical Development Environment. Okay, so this graphical tool has the existing component library, as I shown you in my virtual machine here. This graphical tool has the existing component library. So where I have the existing components, I can just drag and drop the components into my canvas, okay, to develop the application, right? You can also create the user-defined application with the help of these existing components, right? So by using this component suite and user-defined components, by writing any shell commands here, you can develop the user application. So this user application will be stored in the repository. Okay, so now I will configure my GDE to connect with the repository as well as to connect with the co-operating system. This scope and this CME will be installed on the native operating system, right? So whenever you click on the run button in GDE, so the code will be deployed into the native operating system with the help of this co-operating system. So you will work on the GDE only, and whenever you perform the saving operation, like we will call this a check-in and checkout operation. You have to check in the code into your EME. Similarly, you have to perform the checkout operation to get the code from EME to your local machine, right? So this EME is used to perform check-in and checkout operation and version controlling, and this co-operating system is used to convert the graphical code into the Unix understandable format. So this is the architecture here. So if you have any questions about architecture, you can go ahead, right? So this is the graphical tool. Okay, so co-op also will install on the server actually, right? So I will configure my GDE to connect with the server. Here I will configure my GDE to connect with the server. I will show you all the configuration settings in our regular sessions. Okay, but here if you have any questions regarding this architecture, you can go ahead. Otherwise I will move to next slide. Hello Mamata. Hello. Hello. Am I audible? Hello. Hello, Mamata? Hello? Hello?
Hello, can you hear me? Hello.
Yeah, now I am able to hear you. I don't know why.
I don't know what happened.
Yeah, fine, good.
Sometimes
So,
your
did you miss anything?
voice, sometimes your
Yeah.
audio is breaking. I don't know why.
So, my voice is breaking?
Because yeah, sometimes it's breaking.
Okay, now it's fine, right?
Yeah, it's fine now.
Yeah, because network fluctuations. Okay, fine. So, here, did you miss anything here in this architecture? I
No,
mean,
it's good.
you have any questions regarding architecture, or can I go
No.
ahead to next slide? Fine. So this is about
Yeah, you
Ab
can
Initio
go.
product. Yeah, fine, good, thank you. So next thing is, see, so to install the Ab Initio, you can use one-to-one machines, like in networking machines we have one-to-one machines, right? So you can use the same machine to install the Ab Initio co-operating system and to install the Ab Initio graphical tool. Okay, and you can use the many-to-one machines, like you will use only one machine as a control server where I install the Ab Initio co-operating system, and I will install the multiple graphical tools on multiple clients here. Okay, so on one client I will install the GDE, and the client also I will install the GDE. Okay, and only one control server I will install the Ab Initio co-operating system. I will configure multiple GDEs to connect with the same co-operating system. So this is called many to one environment. Similarly, if you take many to many here, you can use the multiple clients. Each client will contain the one graphical development environment, and we have some multiple nodes with one control server, right? On each node you can install the Ab Initio co-operating system to run the process parallelly. So this is also supported by Ab Initio, right? So now coming to CPUs, you can use single CPU computers with single bus architecture, and you can also use SMP system, right? Symmetric multiprocessing you can use with multiple processes. So this is all not required for developers actually. So for admins, what I am trying to say here, this Ab Initio can be installed on single CPU system, SMP systems, and multiple nodes also. That's what I am trying to say here. So this is how you have to connect the GD with the Ab Initio cooperating system, right? So your Ab Initio cooperating system will be installed on the native operating system, as I told in our architecture. Okay, so you can use any of the method here. You can use FTP, or you can use telnet, remote education you can use, right? You can use secure shell method. Any kind of connectivity you can use between the GD and the cooperating system. So most probably we will go with the secure shell only, right? So we have two development environment actually. We have GD and SD. So nowadays, SD is not required for us. We are going with the GDE only. So in the GDE itself, you can write any kind of shell commands, right? So we have GDE nowadays. And next thing is, this is a two-tier architecture actually. So we have some back-end and front-end applications. So in this one, and you can use the FTP tool to transfer the data between multiple servers. This is again different story. So this we need not require in demonstration, right? So this GD stands for graphical development tool. I mean graphical development environment is the abbreviation for this GDE, and which is the graphical user interface, like our all other graphical tools in Windows. Okay, with the help of this graphical user interface, I can develop the applications, right? So which will be connected with the cooperating system to run the job, right? And next one, this is about the cooperating system, so which will install on top of the operating system. So here the COP can interact with the multiple GDEs also, which units a network of computing resources. I mean, multiple CPUs, multiple storage disks you can connect with the cooperating system. Okay, so which will be running on the IBM AX and Solaris. So many ways are there. I will show you the all support ways here. So this is the host settings. Anyhow, these host settings I will show you in our regular session, how to perform host settings and all. Okay, generally in our real-time applications we have to use any kind of method here, secure shell method or telnet method. You can pass any host, login, password you can use here. Okay, so let me come back to previous slide where I have the all operating system which can be compatible with the Ab Initio. Okay, so here this is the operating systems, okay, which can be compatible with the Ab Initio. You can use Sun Solaris, IBM AX, HP UX, Siemens. Okay, you can use Windows, Red Hat, Linux. You can use any operating system. And coming to databases also, so because we have to interact with the databases, So all these databases are compatible with the Ab Initio software. You can use Oracle, Sybase, Informix, Teradata. You can use any other databases, and you can also go for third-party tools for data migration activities if you want. You can use Trillium, Edwin, Sibyl, etc. Okay, so this is about the basic things about Ab Initio. So here we have the sample list of clients. This PPT was prepared in 2011 actually. So then we have the sample list of clients. So insurance, we have insurance clients, telecommunication, right? We have credit card clients, banking clients, finance, e-commerce. So many customers are going with the Ab Initio nowadays. Okay, and coming to this software, so see in our real-time applications, I mean we have the 3.1 as the latest version nowadays, but to practice in our regular sessions, we have the trial version. The trial version is 2.10. We have few differences between this trial version and the latest version. Okay, so what we have to do is we have to first practice on the trial version. So once we are comfortable with the trial version, while explaining about each component in trial version, I will tell you about the differences between the new components in 3.1 version and in this 2.10 version, right? There are few additional parameters and there are few changes in the latest version. I will provide some screenshots with the help of this Ab Initio help file to explain about the differences between the trial version and the latest version, because if you want to practice on latest version, it is very, I mean, you have to spend more dollars to get the license for the latest version, right? So we cannot practice on latest version, right? So we have to practice on trial version and then we have to move to latest version whenever you get the chance to work on the Ab Initio. So there won't be any complexity because there are only few differences between these two versions. I will clearly tell you, I mean I will clearly explain about the differences between the trial version and the latest version. Okay, so to install this Ab Initio co-op, you have to,
Sorry, I didn't
yeah, yeah,
hear you.
please. Is any questions you have?
No, actually, sometimes your voice is breaking.
Oh, now is it audible?
Yes, it's fine now.
Fine.
Yeah, it's fine.
Yeah, thank you. Fine. So, any questions you have? Because once we start the regular session, then only you can understand about these things.
No, you can go ahead.
Fine. Okay, fine. Okay, fine, Mamta. Right.
Yes.
Yeah. Shall we wind up the session now? Hello?
Hello?
Yeah, shall we wind up the session now?
Hello? Yeah, sure.
Yeah. Sure. Thank you.